Hey, I'm Gavin, and I'm going to tell you a little bit about the decline of the now functionally extinct American chestnut tree and some pretty cool things that are happening in science right now that may allow us to repopulate the Appalachian forest with American chestnuts. So, the main thing you need to know about the American chestnut tree itself is that it was like the redwood of the East before its decline. They were these huge trees known to reach heights over 130 feet, and not uncommonly either, and like have just massive, massive trunks. I think the biggest stump on record was just under 20 feet in diameter. And they were very abundant too. It's estimated that there were, excuse me, it's estimated that there were between 3.5 and 4 billion American chestnut trees at the turn of the 20th century when the blight struck. And at the heart of their range, which, as I mentioned, coincides with the Appalachian Mountains, at the heart of their range, you would find that 1 in 4 trees were an American chestnut. And so not only were there so many of them, and not only did we lose the ecological benefits that are provided by all trees, regardless of species, just by forming the forest ecosystem and just by being trees, superorganisms that just simply by existing, especially such a big tree like the American chestnut, simply by existing, they create their own communities. So, in addition to losing that, we also lost the unique benefits provided by the American chestnut tree. In particular, the nut itself, which was the provider for the ecosystem, like a big provider for bears, deer, turkeys, and actually the passenger pigeon fed on American chestnuts largely, and the American chestnut definitely played a role in the extinction of the passenger pigeon. And then economically, they were very important for people too, like in addition to their ecological importance. The 3 main Appalachian industries at the turn of the 20th century were said to be chestnuts, hogs, and moonshine. And when we lost the chestnut tree, well, the pig farming industry also took a major hit because it was a common practice for farmers to allow their hogs to graze the forests at the edge of the properties and graze for chestnuts. And so what this did was eliminate the need to feed hogs, the cost of feeding the hogs for a major portion of the year, and also the other maintenance that comes with keeping hogs. When they're out of sight, out of mind, you're not doing all those things. But eliminating that cost allowed farmers to keep higher numbers of livestock, and when it was no longer a viable option to let them graze the forests, well, then they had to pay, and many couldn't, and the farms failed. To make matters even worse, at the time when the most American chestnuts were dying, when the blight was spreading the fastest, coincided roughly with the Great Depression. So, in addition to all of the economic hardships felt during the Great Depression, a major natural resource was lost, and a natural resource that was a free provider of food, protein all winter long for anybody capable of walking through the woods. Then there's also, the obvious cultural loss. I mean, it was the most abundant tree of a region for a long time. I would liken it to the loss of sugar maples here. And, tapping of sugar maples is something that, at least in my family, has been passed on from generation to generation for years. So yeah, obviously the loss of the American chestnut was tragic, and what made it even more tragic is that it was kind of the first extinction of a tree species that was caused by man. And the way man caused the extinction of the American chestnut tree, the functional extinction, by the way, there are still chestnut root systems that are sending up shoots that long ago would have been capable of producing their own trees, but now the blight kills them before this is able to happen. Anyway, man brought this chestnut blight to the United States on Asian chestnut tree varieties used as landscape trees, orchard trees, what have you. The most common one I see out in the field is the Chinese chestnut, so that's how I will refer to Asian chestnut varieties from here on out, because it's just what I'm used to seeing and saying. Anyway, and the way that this blight kills kills a chestnut tree is it forms a canker. And so basically this fungus, it enters the tree primarily through wounds, like, for example, like a pruning wound. So it enters through wounds, and that's where it gains access to the most nutrient-dense tissues that the tree has to offer, and those are the ones that the fungus is equipped to consume, to digest. And so as it gets in, it basically just works its way all the way around the tree, and then we call it girdling. And so I like to think of trees as like bundles of straws, and only the outermost layer of straws is actually like functionally alive. But as the fungus severs these straws, it disrupts the pathway that allows the water and nutrients to go from their sources to their sinks, where they're where they're used to carry out their biological functions. And so as a straw is severed, well, the part of the canopy associated with that straw is no longer getting its the resources that it needs to carry out its biological functions, and that's that. It's dead. So that's how the chestnut blight kills a tree. I would liken it to like choking another human being. Like once your brain's depleted of oxygen, you're done. So that's how it works. Now here's the cool part, the fun part. I'm talking about how we may be able to bring this species back someday. So in my paper, I talk about biocontrol, and I'm not even really going to touch on that because it's kind of largely been abandoned as a means of repopulating the American chestnut population, but it is a valuable tool to be used in the other tracks of the efforts, because it can prolong the life of a tree, maybe sometimes even long enough for the tree to produce nuts, where it can be used in either hybridization or transgenics. So a little bit about hybridization. Hybridization has been happening for, I guess, hundreds of years, really, even by people in agriculture. But in trees, the way we use hybridization, the first thing that comes to mind for me is hybrid elm trees. I plant a lot of hybrid elm trees. And many American elm trees died due to another fungal pathogen, Dutch elm's disease. So the idea here is that, well, we want to repopulate our city streets with elm trees that have elm features, American elm features, but won't get the blight. So or Dutch elm's disease, or in the American chestnut case, the blight. So we've hybridized them. We've crossed the American elm with Siberian elms and even Chinese elms, trying to retain those American elm features, but get the blight resistance of those like Siberian and Chinese species. Anyway, with the American chestnut, this is being tried using Chinese chestnuts to get that blight resistance. But the downfall here is that these hybrid trees, they're not well adapted to live in the Appalachians, right? For the same reasons that the American chestnut never had a reason to become chestnut blight resistant, while the Chinese chestnut didn't have a reason to adapt to the Appalachian forest's conditions. So how we overcome that is by what's called back crossing. So we have to take these new hybrids and cross them back with American chestnuts again. Now, when you do this, for one thing, it takes time. Trees don't, seedlings don't make nuts. So it takes time before you can even do that back crossing, and then your back cross, you might not retain that blight resistance. So it takes many generations to get the desired feature, and even still, you're left with a product that's not, its genome doesn't completely match what your target species is. In this case, the American chestnut. So there are some obvious downfalls there, but it's I guess it depends on who you ask, but it's better than not having than not having that species. It could still potentially we could still recover some of the lost benefits of the American chestnut through a successful chestnut hybrid. Now, what I'm really excited to talk about here is transgenics, the idea that maybe we can recolonize the Appalachians with American chestnut trees by adding a gene from another organism to the genome of the American chestnut, um, a gene that would somehow give it a resistance to chestnut blight without altering the rest of the genome. So this way, we're left with a more truly American chestnut. I keep wanting to say elm here. American chestnut tree that is true to genotype, or excuse me, true to genome, other than this one inserted gene. And so the way that they're doing this right now, the charge is kind of led by Dr. William Powell of SUNY College of Environmental Science and Forestry. So they've taken this gene that originates, it's actually found in many plants, but they've taken it specifically out of a wheat plant. They've chosen wheat because, well, if humans are going to be eating these transgenic chestnuts, well, they're more likely to eat them from an organism that that's already a part of their everyday diet than from, say, like I think a frog was a prospective donor of this gene too. But anyway, what this gene does is it stimulates the production of oxalate oxidase, and maybe I have those two words switched around. Doing this notes free here, and basically this compound is capable of breaking down oxalic acid, and oxalic acid is one of the compounds that the blight fungus uses to break down those vascular tissues in the tree. And the way that they've inserted this gene into the American chestnut tree is, first of all, they did it at the embryonic stage. So well, I'm running out of time here, and I would love to get into that. I think it's so cool. But basically, they've taken a bacteria that in nature is able to basically edit the genome of its host, and it edits its host's genome to basically make food for itself, make nutrients that are only consumable by this particular bacterium. And scientists have been able to basically harness the power of this bacterium and get it so that they can insert whatever gene they want into it, and this bacteria will then insert that desired gene into its target. So I don't know. It's really cool, and I don't think that even though, yes, this tree will be nearly fully American chestnut, I don't think it's that we're going to be able to necessarily use this technology to restore that utopian Appalachian chestnut filled forest that that it once was. But I think the true value of this technology is it's in the future. Another blight, another something, whether it be an insect or what it is going to kill another species. I mean, I can't tell you how many ash trees I've cut down this year. And if this technology had been around before emerald ash borer struck, and it's a little apples to oranges. Obviously, a fungus and an insect, but maybe we'd be able to do something before a species is completely gone. I don't know. Yeah, if you can't tell, I love trees, and I'm out of time. Sorry for rambling.